Hi guys, and welcome to this video on turning points. So what do we mean by a turning point? Well, see this black function here? It kind of turns, doesn't it? It turns and changes direction. So we say this is a turning point and this is a turning point. But because there's two different ones and they look kind of different, we have to give them a more of a unique name. So we say this is a maximum turning point and this is a minimum turning point. Now you'll notice that we can't say this is the maximum point of this function because this is higher. We can't say this is the minimum point of this function because these are lower. On some, and you should have done a lot of quadratics by now if you're watching this, you've seen maximum points and minimum points and probably completed the square to find them. This is another way. So if I drew a tangent to these turning points, this is the important bit. If you draw a tangent, so a line that only touches the function at one place, if we find the gradient of those tangents, you'll see that they're actually horizontal. There is no gradient. So what we say, the gradient function at a turning point will always equal 0. So that's a really important message to understand. Now let's look at the black question I've written at the bottom. So what do we expect the equation of this graph to look like? Now that's really important because if we know the shape of the graph, we can identify maximum and minimum points very easily. There is another way, there's a better way I would argue, but not at this stage. Okay, if you're watching this video, we're looking at IGCSE differentiation, not A level, and so we'll take it to another step when we need to. So let's go back to that question. What is going to be on this right hand side of this equal sign? Have a think. And hopefully you're shouting at the screen, it's going to have an x cubed in it. It could have x cubed and plus 3x squared and blah 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 blah, like plus 2 for example, because there's a positive y-intercept up here. That's not the important bit, it's this part here, the x cubed. And that's always going to tell me that the graph will start in the bottom left quadrant. It will then turn, so I'll have a maximum point. I'll then have a minimum point and then it will go up. And in a later slide I'll show you why that's really important. And just while we're here, just want to talk about this. So this function here, we would say every point along here, this graph has a positive gradient, and then between these turning points we would say there's a negative gradient, and then once again after this turning point there'll be a positive gradient. So the gradient actually fluctuates between positive to negative to positive. Let's have a look at another one. So let's just go straight to this question at the bottom here. Hopefully you're thinking, wow, I know what this is. This is a happy quadratic, so it's going to have x squared. So it will have some other stuff, x squared like plus 2x minus 8 for example. But the important bit is that it's x squared. Now this turning point would be the lowest value on the graph. So this is a minimum value, and this graph would not have a maximum, okay, because there's only one turning point. How about this one? This is a minus x squared. This is an unhappy quadratic. And this, at this turning point, oh, that's a really bad tangent, do apologise. This only has one turning point, and it is a maximum turning point. Okay? So it's really important you understand when you see the function, you'll go to the highest power. If it's a squared, you know it's happy or sad. Just look for a negative. So now we've got something a little bit different. You probably haven't seen too many of these before. But it kind of looks like x cubed, right? But x cubed normally starts here. What's actually happened, it started up here. And when you do transformations later on, you'll understand how to identify these a lot easier. But for today, what you need to understand is this is a minus x cubed. It's been reflected up into this box. And when we reflect graphs in this x-axis to change its starting quadrant, it's always a minus version. So happy and unhappy, that should make sense to you. So x cubed would start in the bottom left, minus x cubed. And you can see, because there's two turning points, it's x cubed. That's not always true, there can be one, but for the majority of the ones you're going to see, there will be 2. Always one less than the power you start with. So let's have a look at a question. So find the turning point of this graph here. So y equals x cubed. So that's the highest power. That's the bit that's important to us. So if we make a very quick sketch here, x and y, it's got a plus 4. So if I just draw something like that, it's going to be roughly right. But we're expecting a maximum and a minimum. So we should get out 2 x values, x1, x2, and the first one, the lower down the x-axis, is going to be my max, and the furthest up is going to be my minimum. And that's how we're going to identify the nature of the turning points. Like I said earlier, there is a better way, but we're not there yet. So to find a turning point, we have to find where the gradient is 0, because that is where the graph turns. So what do I want to write here? I'll just write, so it's a turning point when dy by dx equals 0. So that means we need to find dy by dx. So in fact, I'm just going to write that as a separate thing, and then I'll do that. So gradient function, dy by dx, every term separately, times by the power, reduce the power by 1, times by the power, reduce the power by 1, and these constant terms, they just disappear. Set this equal to 0, and now we have to solve it. Okay, quadratic, everything's already on one side, that's our first thought process. Now we've got to think, well, can we factorise it? And right now, yes is the answer, but you're probably thinking a 2 bracket factorising because it just looks like it. But it's actually a 1 bracket because 3 is common to both, but I'm not actually going to do that. And if you do it, you'll get dots, but what I'm about to do will give you dots anyway. Because it's an equation, I can do the same to both sides. So I always look, is there something I can divide everything by? If the answer is yes, I'm probably going to do it. If it's not an equals, so it's not an equation, just an expression, I would factorise for that value. But because it's an equation, I'm going to divide by 3, and there you have it, dots in disguise. So I'll just show you over here, if I was to factorise it, I would have that, and then I would divide by 3 to solve it. So I end up here anyway. So I am going to factorise. I could have popped this on the other side, but it's not. I recommend this method. So we get 2 values, minus 2, and x is 2. Okay, now time to find the y value. So here we have a formula for y. Here we have a formula for gradient. We want the y, so we can use this one. So minus 2 cubed minus 12 lots of minus 2 plus 4. Minus 8 plus 24 plus 4. What's that, 20? So we have minus 2, 20. Let's pop the 2 in. So y is equal to 2 cubed minus 12 lots of 2 plus 4. So what's that? 8, take away 24, minus 16, plus 4, minus 12. Oh, slight voice break there. So 2 minus 12. So they'll often ask you to determine the nature of them, and we're going to do that, like I said earlier, by understanding the shape. It's an x cubed, so we know it takes this shape. Minus 2 is the further down the x-axis, so this must be my maximum. And this one, the x value is 2, so it's further to the right. This must be my minimum. I've just done that, so okay, that's it guys. So hopefully that all makes sense. Just differentiate, set it equal to 0, solve the quadratic, and then understand the shape of the graph. Good luck.